Good morning, everyone. Today we're going to be starting with our section Stats Medic 4.1, Day 3. And this is looking at other sampling methods, specifically cluster sampling and systematic random sampling. If you will remember, when we did our work yesterday, we were looking at specifically the stratified sample. And the day before that, we did a look at simple random samples. So we're basically just going to add two more sampling types to our tool belt. And let's take a look. Okay, so this is the same setup as before. In the next city, Taylor Swift's concert promoter again wants to find out how much fans enjoy her concerts. So they're going to ask fans from 1 to 100, where 100 is the most. How much do you enjoy the concert? Again, we're going to take a sample of 10 fans from that first section right in front of the stage. As a quick review, we started with a simple random sample. So there are 3 steps here to doing a simple random sample. First thing we're going to do is label each member of the audience. The next thing we're going to do is we're going to select 10 random numbers from 1 to 50. And then we're going to select the seats with numbers matching the random digits. So I think I have the wrong chart over here, but since this was from yesterday, I think you'll understand. We're looking for person 11 to be included in the sample, person 29 to be included in the sample, etc., etc. Okay, here is our correct map of the seats. Notice that seat number 11 is selected, seat number 29 is selected, seat number 7, etc., etc. Okay, now that we have done our little bit of a review on a simple random sample, we're going to look at what's going to be called a cluster sample. So it says, yesterday we decided a row would have a big impact on the enjoyment. So this time we're going to do a sample of an entire column. Okay, this is important because we're going to make sure that every row has a set number of seats included in the sample. So we're not undercovering any of these rows. For example, it's never going to happen with this method where we have no people selected from the last row, because the last row will be included in all the clusters. So what are the clusters going to be? Well, we're going to paint every column a different color like we did here, and each one of these columns is going to be a cluster. So to reiterate, we're going to take, for example, if we choose the yellow column over here, every person in the yellow column is going to be included in the sample. And if we include this orange column over here, every person in that orange column is going to be included in the sample. Now I could just unadvisedly, I could just think of 2 numbers off the top of my head, but then that might introduce some kind of a bias here. So we're going to label all of these clusters from 1 to 10. And then we just need to use our random number generator, or maybe we could even use dice to get a number between 1 and 10. It doesn't really matter which random device you use, as long as you use a random device. So here we are with Google, and I'm going to just choose a 10-sided die. Get rid of that one. If you're playing Dungeons and Dragons, I'm sure you know a 10-sided die does exist. We're going to roll that 10-sided die, and then we're going to get number 4, and then we're going to get number 10. Let's circle number 4 and 10. So now everybody sitting in either an orange seat or a blue seat is going to be in our sample. Okay, question A. Why would sampling all the fans in the column give a good estimate? We already talked about this, and we said that since each column is going to include a fan from all of the rows, each of the 5 rows, there will be no row that is undercovered. In other words, there is no way under this scheme to have one fan, only one fan from the 3rd row, or no fans from the 1st row. Every sample that we produce using this cluster method will have 2 fans from each row. Moving on to this one, how many columns will we need? We'll need 2 columns, and randomly choose those. So I think we're done here with method 2. Is this going to produce a good sample? I don't know. We'll see what the cluster sample dot plot looks like, and then we can decide from there. Let's take a look at method 3. Method 3, Taylor's manager thinks it's important to sample fans that have a different view of the stage, so he wants to sample every 7th fan. So first we need to figure out the starting fan. So we're going to randomly select a fan. Now it doesn't have to be in the 1st row, it could be anywhere. So let's number the fans. And then let's take out our calculator and select a random number between 1 and 50. I think there were 50 fans. Let's take a look. Yep, there were 50 fans. And now we'll select our starting place. So here we go. To do that, we'll click Math, Probability, Random Integer, which is number 5. Our low number will be 1. Our upper number is going to be 50. And then we're going to only select one fan from 1 to 50. And we're going to start with person 25. All right, let's highlight number 25. And then we're going to count every 7th seat. So 25 is 1, 2, 3, 4, 5. Sorry. 25 is 0. 1, 2, 3, 4, 5. So there's number 30. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh wait, we were supposed to do every 7th seat. All right, so let's back up and do this again. Every 7th seat. So 1, 2, 3, 4, 5, 6, 7. That's going to be seat number 32. Okay. 1, 2, 3, 4, 5, 6, 7. Now this is going to be seat number 39. 39 plus 7 is 46. And then now this is an interesting one. I can't continue. There's no more seats here, so I'm going to start over at the top again. So 1, 2, 3, 4. We'll go back to number 1. 5, 6, 7. So that lands us at seat number 3. 3 plus 7 is 10. 10 plus 7 is 17. And then now we should count and see how many we have. We've got 1, 2, 3, 4, 5, 6, 7. We need 3 more seats. 17 plus 7 is 24. We need 2 more seats. 24 plus 7 is 31. We need 1 more seat, and that's going to be 31 plus 7, which is 38. So every 7th seat, and we start at the top when we need to. And now we can ask this last question here, is which method do you think is best? And again, this is kind of subjective, so answers will vary. So answers are going to vary. If you choose a cluster sample, you're probably going to say that you're going to ensure that every row has 2 seats selected. Systematic sample has its virtues because, well, it's easy to implement and you don't even really need to number all the seats. You can just count in your head, count 7, the next 7, the next 7, etc., etc. We did have to use some kind of a randomization, though. We did have to randomize where we started. So don't think that it's going to be necessarily a convenience sample, because we did use some kind of randomization method. So it's time to look at the actual data. So we're going to compute our averages. Now we already did sample 1. It is the same simple random sample that we did before. And if you remember, that average was 84.5. All right, sample 2, let's bring that up. Sample 2 was everybody from column 4 and column 10 included in our sample. So let's circle those samples. That's everybody in the 2 red circled columns. We have their scores in front of us. So now we can calculate the average enjoyment level here. That's going to be 88 plus 88 plus 67, 73, 68 again, plus 84, 83, 65, 67, and 68, which adds up to 751. Great, so our average enjoyment level is 75.1. Moving on to the systematic random sample, we have these seats selected in our previous method, or in the method we just did. Let's highlight the scores from each of those seats. And then let's go ahead and compute the sum of the scores. So we have 90 plus 84 plus 90 again, plus 67 and 81, plus 72 and 68, plus 70 and 68 and 66. That gives us an average of 75.6 a sum of 756, and an average of 75.6. Great. Now, just like the previous lesson, we're going to say, okay, if we were actually doing this, we would get this one average and we'd have to go with it. But since this is academics, we can actually take a look at all the things that could have happened. So now we're going to take a look at what could have happened. And since we asked everybody in class to do a separate sample, we can compile everybody's samples together and take a look at what happened. So this is the same SRS that we did yesterday. And notice that this time I've added the key that each dot is going to be one sample of 10 fans. So just like yesterday, the SRS, although it is centered right around 80, the variation here is very large. So it's hard to tell whether or not, or if we had just one average to go on, we shouldn't feel too confident that we're actually close to the true average enjoyment. Now, if we take a look at the cluster sample, this is the cluster sample that one of my classes did. This is a little bit better. We have a peak right around, what is that, 79? And the variation here is much lower. In other words, if I computed the standard deviation or the IQR from the cluster samples, that would be smaller than the IQR or the standard deviation for the cluster sample. Cluster sample has less variation than the SRS. So if I have one dot here in isolation, I could feel pretty secure that it's not an outlier dot because the method, when done correctly, produces a sampling distribution of samples that has very low variation. Let's take a look at the simple random sample, and oh, look at this. We have a couple of dots out here which are really low averages. And again, if each dot is a sample of 10 fans, this one seemed to overestimate the mean. I think this might have been a lot of people started in the first row, since that means we're going to get a lot of repeats in the first row. But again, the variation here is low, even though it may not be as accurate as we want. So both of these methods, if done correctly, will produce a distribution of samples that is centered at the true population mean and with low variability. And that's really what we're looking for. We're looking for a method. Let me rephrase. An optimal sampling method is going to produce samples that are accurate, in other words, near the population mean, and consistent, in other words, low variability. Okay, now that we have that, we can get to our important ideas. And we've got a cluster sample, and a cluster sample is, first we split the population in groups based on location, usually. And then we're going to use an SRS to choose groups. Now, in a cluster sample, you're going to sample all the individuals in the group. Since a cluster sample is often confused with a stratified sample, one thing to think about is in a cluster sample, the groups are going to be heterogeneous. In other words, when we did our clusters here, each person in the cluster came from a different row. So there is a difference between each person in a cluster. Whereas in a strata, everybody in the strata was from the same row. So that's why we're calling it homogeneous. So heterogeneous versus homogeneous groups. Now the systematic random sample is an easy sampling method to work with, but you do need to randomly choose a starting position and then sample with an equal interval between each samples or between each individual. So in other words, every 7th person or every 5th person, however it is you want to do that. Okay, and then we're going to talk about the benefits of the different samples. SRS is unbiased, meaning that the center of the distribution is going to be the population center. Stratified samples are also unbiased if done correctly, and it will produce low variability. Cluster samples are easy to do and also will be unbiased if done correctly. And systematic samples is nice because you don't necessarily need to label the entire population. So it's easy to implement, and if done correctly, also will be unbiased. All of these samples that we've talked about, all 4 of them, will produce an unbiased sample. In other words, the mean of the distribution of samples will be the true mean of the population. But again, they have to be done correctly. Now that we've done that, let's take a look at our Check Your Understanding. And in our Check Your Understanding, the setup is this. We have a large hospital, and we would like to survey patients on their level of satisfaction with their hospital room. The hospital has 10 floors, so it's a pretty big hospital. Each floor has 15 rooms for a total of 150 rooms. And the hospital staff would like to take a sample of 30 rooms. So now we have to decide, if we were actually going to do this, we have to decide what variable is going to introduce the most variability. Would it be the floor? For example, there's one floor that is going to be consistently higher in satisfaction, or one floor that's going to be consistently lower in satisfaction. That could happen. Or is it maybe location? Perhaps all of the rooms on the, let's see, that would be the south side of the hospital. They would have sun-facing rooms for most of the day. Maybe they're satisfied. And the ones who are able to see the sunrise, maybe they have a higher level of satisfaction also. This means that the north side of the building would never get any direct sunlight. Maybe their satisfaction level is less. So I don't know which one of those make the most difference, and depending on what you think the most difference is, that's going to dictate your choice of sampling methods. So number one, let's describe how to take a stratified random sample of the 30 rooms. Okay, well, I can already see that perhaps we should make each floor a strata. So if we make each floor a strata, then we would do a simple random sample from each floor. Let's take a look at what we have. We're going to use the hat technique, and we're going to have each floor as a strata. Now, I'm saying use the hat technique because if you'll remember from class, we have three different techniques that will produce a simple random sample. One of them is the hat technique that we're going to look at here. The other one is to use technology, like we did before, like we did in our previous work today. And then another one would be to use a random device, like a coin or maybe dice. I like to go through all of those when we do this check your understanding. So with the hat technique, we're going to let each floor be the strata. So there are 10 strata total. For floor 1, so the ground floor, we're going to write the room number of each room on a slip of paper, and then we're going to place each slip of paper into a hat. Without looking then, we're going to draw 3 room numbers from the hat, and we're going to include those rooms in the sample. And then we're going to repeat the process for the remaining 9 floors. 10 floors total, 3 rooms from each floor. That's going to be a sample with 30. Now, I like the hat technique. You can use it in almost every situation. And if you memorize how it's done, then you will always have a really good response. So hat technique comes recommended. Next, how about the cluster sample of 30 rooms? Well, what would be the cluster? And one way to think about the cluster would, again, be the floor. And if we're going to do a cluster sample, that means that we're going to choose an entire floor to be included in the sample. If there are 15 rooms on each floor, that means we need to choose 2 whole floors for our sample. Let's use a dice technique. This is going to be a random device. So each floor is going to be a cluster, meaning there are 10 clusters. We're going to not use a fancy 10-sided die or a 20-sided die, and we're going to use just 2 6-sided dice. And then we're going to roll them until we get a sum between 1 and 10. Now, we may have to roll the dice a few times until we get something between 1 and 10, but that's okay. It won't take that long. And then we're going to repeat that process. We're going to roll again until we get 2 different numbers between 1 and 10. All the rooms in the floor numbers that match the sum are included in the sample. So if we roll a 2 and then we roll a 9, then all the rooms from floors 2 and 9 will be included in the sample. So that's a dice technique. Don't shy away from it with the sums. This is really good. You know, either you have 1 die or 2 dice that should cover most of the techniques or most of the situations that we're going to do, especially in class. Next, we're going to use a simple systematic random sample for 30 rooms. Now, how do we do this? Well, all we really need to randomize is where do we start? So, using technology, we're going to write a list with each room number from 1 to 150. 10 floors, 15 rooms from each floor. That's going to be 150 rooms on a list. We're going to use a random number generator from 1 to 150 to select one of the rooms. The room with that list number that matches the number from the random number generator is going to be selected for the sample. So if our random number generator gives us 110, then the 110th room on the list will be on the sample. And then we're going to select every 5th room on the list until we get 30 rooms selected. When we reach the bottom of the list, we're going to return to the top of the list and continue choosing every 5th number. So when all 30 rooms on the list are selected, those 30 rooms are included in the sample. Okay, as you can see, there's not a whole lot of difference between dice and technology other than the terminology, using a dice instead of a random number generator. And yeah, so that's our question 3. Question 4, what are the benefits of using each of the 3 types of sampling methods in this context? Well, let me tell you. Number 1, if you use a stratified random sample, that means all the floors are going to be included in the sample and no floor will be undercovered. Variability due to floor number is going to be reduced since every floor will be included in the sample. Now, if you choose to use a cluster sample, number 1, logistics are simplified because you only need to visit 2 rooms or 2 whole floors. You don't have to visit every floor in order to do this. And also, something to think about is all room locations on each floor are covered in the sample. We have all the north rooms, all the south rooms, all the east rooms, and all the west rooms. So if there's any variability due to room location in the floor, that variability will be reduced. Lastly, systematic random samples are easy to execute. That is their main virtue. If there's variability due to floor, that's probably going to be reduced because all the floors will be covered in the sample due to the fact that we're taking every 5th room. Since we're taking every 5th room, all the floors will have a floor in the sample. So that is it for chapter 4, section 1, day 3. And we'll see you next time when we do day 4.